Hi dear students, now we will derive an expression for orbital velocity of a satellite. We will consider a satellite of mass m, okay, which is at a height of h from the surface of earth and it is revolving around the earth. Okay. If the satellite has to move in a circular orbit, then on the satellite there will be two forces. One force will be centripetal force or centrifugal reaction, which is acting outward, radially outwards, and the other force is the gravitational force of attraction between the earth and the satellite. Okay, if the gravitational force will become more, then satellite will fall into the earth's surface. If the centripetal force becomes more or the centrifugal reaction becomes more, then the satellite will escape from the earth's pull. Okay, so the essential condition for the revolution of a satellite around the earth in a circular orbit is centripetal force should be equal to gravitational force. So what is the equation for centripetal force? Centripetal force is equal to mv square by r. Okay, so that should be equal to gravitational force. Gravitational force between the earth and mass is equal to g into mass of the earth into mass of the satellite divided by r square. R is the distance between the earth and the satellite. Okay, so basically this distance is equal to re, okay, re plus h. Okay, now what we can do, we can cancel this m, mass of the satellite gets cancelled. When the centripetal force becomes equal to gravitational force, the corresponding velocity, we can write it here, orbital velocity, and one r gets cancelled. So what happens? Orbital speed VO is equal to square root of gme divided by r. But we know that here r means the distance between the earth and the satellite is also equal to re plus h, radius of earth plus height of the satellite. So therefore what we can do, this can be written as square root of gme divided by re plus h. Now one more thing is, from the equation of acceleration due to gravity on the surface of earth, g can be written as g is equal to gme divided by re square, gme divided by re square. So what can be done? We can substitute for this gme. What is gme? In the place of gme, I can write it gre square. So what happens? This equal to square root of gre square, okay, divided by re plus h. So you can use any one of the forms as the equation of orbital velocity depending on the situation. One more thing is, okay, if the satellite is very close to the surface of earth, okay, if the satellite is very close to the surface of earth, then what happens? That height of the satellite will be very less than the radius of the earth. Okay, if h is very less than re, then re plus h will be approximately equal to re. Then what happens? One re gets cancelled. Orbital velocity will be equal to square root of g into re itself. That means if the satellite is very close to the surface of earth, then h is very small. Then the orbital velocity is given by square root of gre, or you can say like this: for a surface satellite, orbital velocity is square root of gre. Thank you very much.